Picture this. You're at the front of the room, delivering a perfectly structured lesson. You've prepared for hours, but when you look at the crowd, you see this. It is easy to look at that sea of blank stares and blame the students. Society points to shrinking attention spans, TikTok, or a general lack of motivation in a new generation. But the source of this disconnect is rarely the students. It is a hidden cultural divide between the subjects themselves, a clash of different intellectual worlds. In the late 1980s, researcher Tony Betcher interviewed over 200 academics across 12 disciplines. He discovered that a university functions less like a single school and more like a map of isolated tribes. These tribes are so distinct that their cultures even dictate how they spend their weekends. Betcher found that members of the physics tribe overwhelmingly spend their downtime attending the theater or listening to classical music. The engineering tribe, however, gravitates toward active, physical team sports. Imposing the teaching customs of one tribe onto the territory of another creates a friction that halts the transfer of knowledge. In the 1960s, educational theorist Joseph Schwab identified the source of this friction. He argued that all academic disciplines are built on one of two architectures, syntactical or semantic. Syntactical disciplines like math and physics treat truth as a procedural journey toward a single correct answer. We can visualize this structure as a rigid railroad track running from point A to point B. In this world, creativity is an error. If you deviate from the formula, you have simply derailed the train. Then there are semantic disciplines, like history and literature. Here, truth is interpretive. Two people can examine the same data and reach two different yet valid conclusions. This architecture is more like a hot air balloon floating over a landscape. The goal isn't to follow a track, but to map an open terrain and connect disparate ideas into a cohesive view. Evaluating a balloon-riding history student with the rigid metrics of a physics test leads to a total misalignment of goals. But the subject is only half the problem. The other half is the architecture of the student's brain. In the 1950s, cyberneticist Gordon Pask began investigating how we process complex systems. Pask developed the Musicolor machine, a device that translated piano sounds into a responsive light show. By studying how performers interacted with the system, he realized that people process information in two distinct ways. The first is the serialist learner, step-by-step thinkers who thrive on sequential logic. They need step 1 before step 2. Zooming out reveals the holist learner. They need the big picture, understanding the context of this interconnected web before focusing on individual steps. When a serialist teacher forces a holist student to memorize formulas without context, the cognitive process fails to engage. The glassy-eyed student is rarely a discipline issue. It is a system crash caused by feeding the wrong cognitive code to the wrong processor. Solving this mismatch requires aligning our teaching with the architecture of the subject. Let's look at the syntactical disciplines first, the rails. For subjects like math, teachers can use backward design. You define the final objective first, build the test that verifies it, and lay the tracks backward to the start. Semantic subjects, like literature, require the opposite, forward design. Lawrence Stenhouse argued that setting rigid, mechanical goals in the humanities is like giving people a blueprint to dig trenches without asking why the trenches are being built. Instead, teachers in these fields can act as gardeners. You plant complex texts and problems, then allow an organic, unpredictable understanding to grow. Successful instructional design requires a blueprint that matches the actual terrain it is built upon. This alignment also applies to how we grade. Multiple choice tests work for the rails, but they fail to capture the depth required for the balloon. To test semantic knowledge, we can look to the viva voce, or live oral defense. This photograph shows the rigor involved in verifying authentic understanding. Requiring students to defend their mental maps in real time ensures they have internalized the terrain, rather than just memorizing a list of facts. Effective teaching depends on a specific choice, whether to follow the fixed rails of the train or the open sky of the balloon.